Okay, so I've made several videos on how to solve homogeneous second order linear differential equations and non-homogeneous ones. And there is actually one more type or one more problem we can solve using the method of undetermined coefficients. But I want to stop before we do that and just kind of go through a few random examples that I'm going to make up off the top of my head, and hopefully we can solve them to make sure we understand how these things work. So for the sake of argument, suppose we have this. Y double prime plus 13y prime plus, let's see, 30y equals 0. So we say second order linear homogeneous. So all I need to do is look at the characteristic equation. So I say characteristic equation, r squared plus 13r plus 30 equals 0. Hopefully that factors two numbers, multiply to 30, add to 13. Yep. R plus 10, R plus 3 equals 0. So R is equal to negative 10 and negative 3. And now I immediately get my solution. Y equals C sub 1 e to the negative 10x plus C sub 2 e to the negative 3x. And I'm done. And again, these are really straightforward. The algebra to actually work them out, especially when they become non-homogeneous and you have multiple functions floating around, can be rather cumbersome. But as long as you know the possible ways to write your solution, it's pretty straightforward and simple. So suppose we have y double prime plus y prime plus 5 equals 0. It's homogeneous again. We say, okay, I look at the characteristic equation, r squared plus r plus 5y, I'm sorry, I left off the y, plus 5 equals 0, which is clearly not going to factor, so I go with the quadratic equation, negative 1 plus or minus the square root of 1 squared, which is 1, minus 4 times 1 times 5, all over 2 times 1, which is 2, and I get negative a half plus or minus the square root of 1 minus 20, which is negative 19, all over 2, which you all know is negative a half, plus or minus root 19 over 2i. It's complex, so that I know how to write my solution with a complex. I get y equals e to the alpha x, alpha is negative a half, times parentheses k sub 1 cosine of beta, which is root 19 over 2, beta x, had something in my eye, sorry, plus k sub 2 sine beta x, which is root 19 over 2. And again, there we go, straightforward and simple. Solving the quadratic is not a problem. And then it's just a matter of saying, okay, two real distinct solutions, this form. Two real complex solutions, this form right here. If we ended up with repeated roots, if this ended up factoring as negative 3, that would just be negative 3, and then we throw an x in right there. So again, really straightforward. And then suppose we have something like y double prime plus, let's see, we'll go with 10y prime plus 25y equals x squared plus 2x plus 8. And I'm just going to throw out there, I made this up off the top of my head, so I have no idea how messy the answer will be, but we'll see. So first, since this is a non-homogeneous one, I know I need a solution of the form y sub c plus y sub b. So first I find the complementary solution, which means I look at the homogeneous version of this. Y double prime plus 10y prime plus 25y equals 0. Factor that. We'll look at the characteristic first. R squared plus 10r plus 25 equals 0, which factors to r plus 5 times r plus 5. So I get r equals -5 and -5. So then I don't have a repeated root. So y sub c is c sub 1 e to the -5x plus c sub 2x e to the -5x. That's my complementary. Now I do the particular. And we said the trick is, look at this. That's a quadratic. Okay, then my particular solution, y sub p, is going to be a general quadratic. ax squared plus bx plus c. Now I just need to plug this into that, which means I need the two derivatives. Y prime of p equals 2ax plus b, and y double prime of p equals 2a. Now when I plug it over there, I get y double prime, which is 2a, plus 10 times y prime, which is 2ax plus b, plus 25 times y, which is ax squared plus bx plus c, has to equal, and I'm going to have to go up here because I'm out of room, x squared plus 2x plus 8. Now I combine, distribute, simplify, and I get 2a plus 20ax plus 10b plus 25ax squared plus 25bx plus 25c equals that. If I then equate things, 25, let's see, the only quadratic terms, 25ax squared equals x squared, which means 25a has to equal 1, so a is 1 over 25. That accounts for this quadratic term and that quadratic term. Now I look at the linears, and I get 20 times a, 20 over 25, which I'll just reduce to 4/5, plus this, plus 25b, has to equal the linear term on the right, which is 2. Multiply everything by 5, and I get 4 plus 125b equals 10. Subtract the 4, divide the 125, and I get b equals 10 minus 4 is 6 over 125. Not the nicest fraction in the world, but whatever. But now the linear terms, the x terms, are accounted for. Now I've just received word that apparently my wife just walked in front of my camera and is now laughing hysterically off at the side. So thankfully my back was turned so I didn't laugh either. But we'll keep going. So now I just need to solve for c. And as far as constants go, 2 times a, so that'll be 2 over 25, plus 10 times b, that'll be 10 times 6, 60 over 125, plus 25c equals 8. Now just solve this. I really don't want to. We'll maybe try to simplify this a little bit. Common denominator is 125. I don't want to multiply 125 by 25, so I'm not going to. Common denominator is 125. So multiply this by 5, and I get 5 times 2 is 10. So this becomes 10 over 125 plus 60 over 125. So this will just be 70 over 125 plus 25c equals 8. And now, unfortunately, to make it easier on myself, no, I'm not even going to bother doing that. I don't have a calculator, but I'm of the opinion you can solve without a calculator. So, 8 minus 70 over 125 is 7, and 55 over 125. Correct. So we get that is equal to 25c. Now, this is going to be 7 times 55, 7 times 125, 7 times 5 is 35. Carry the 3, 14, 15, 17, carry the 1, 7, 8, plus 55, 10, 12, 13, 8, 9. That should be 930 over 125 equals 25c, and then divide the 125. So c is equal to 930 over 125 times 25. And all of you engineering students with your calculators can store it into your calculator and get it. I'm completely fine with it. But what it means is, now I have A, now I have B, and I have my C, even though it's not completely reduced because I'm not going to take the time. But then I can write my particular solution. It's A, 1 over 25, x squared, plus B, 6 over 25, x, plus C, which is 930 all over 125 times 25, which is only 3,125, I think, so that's actually not that big of a deal. But there we go. There's my particular solution. Here's my complementary solution. To get the general solution, I just add the two together and I'm done. And again, I do stress, all things being equal, these are actually relatively easy. If it's homogeneous, there's 3 possible solutions. 2 real roots, 1 repeated root, or complex solutions. And there's 3 forms for your answer, and you're done. For the non-homogeneous, get the homogeneous one first. And then for the non-homogeneous, look at the thing on the right and say, what does it look like? That's going to be my particular solution. And then I'm just going to find a way to determine the coefficients. We have one more method of undetermined coefficients, one more type of solution we can get, but I was deliberately going to hold that off until tomorrow so you guys can kind of work through this, because at this point I've got like almost 45 minutes worth of videos, and I'm going to have to add another one on top of that. So this will probably be it for today.